Welcome everybody. Thank you for being here today. My name is Tony Terrell, and I'm a technical marketing manager here at TechSoft 3D. And the goal of today's virtual training session is to talk about how we can integrate our Hoops native platform SDKs into mobile applications or mobile platforms such as Android that are based on more of a Java JVM approach. So really the goal of today's training is to get you guys up and running with the Hoops native platform on Android. I don't want to talk too much about the intricacies of the Hoops native platform and those SDKs, or really get into how to use them. We have a lot of documentation on our website surrounding that, and I think that there's people that are experts on that can do that more justice than I can. But what I want to help you guys do is, you might have an app an existing app, that you want to integrate SDKs into, or maybe you want to create a new app from scratch. I just want to give you the pieces that you need to start developing and to pull in the SDKs and hit the ground running. I want to start off and kind of just touch on all the dependencies and different pieces of software that we're going to be using, and how you can set those up so that you can follow along or potentially download and run this at some time in the future. After we get everybody up and running that wants to follow along, I would like to briefly talk about the SDKs, or the Hoops native SDKs that we offer. Specifically, these are SDKs focused on 3D visualization and CAD data translation. So whichever of those fit your needs. We're also going to kind of touch on some brief Android overview for Android app development. But after we touch on that, we have to talk about the Java native interface. And the Java native interface is pretty much the bulk of what we'll be talking about today. And it's essentially the brains behind all of this and the glue that will allow us to run native libraries from within an Android application. After we kind of get that basis built up, we're actually going to jump into, or I will jump into, the Android project that I distributed to you guys. And there's some kind of skeletoned out functions in there, and we'll actually look at what it looks like to pull the SDK methods in and implement some Hoops SDK functionality within this application. So that's about it. After that, we should have plenty of time for questions or help, or just whatever. So looking at the dependencies that we're going to need to run this application, obviously we're doing Android development, so we will need Android Studio. I am using Android Studio 4.1.1. I believe that is their most recent version. Within Android Studio, to use the Hoops SDKs, we need to install the native development kit version 18. Version 22 is the current version. So we do have to go back and install an outdated version, or not a legacy version, I should say. It is still very widely supported. We also need to install CMake, and then you will need to have a valid Python installation on your system that is all set up into your system path variable and all that. So those are sort of the development versions and the dependencies and all that. You're also going to need the Hoops Visualize SDK for Android. That is the bulk SDK that we will be working with today. If you are an existing customer, you can download that through our website at the Developer Zone. If you are not an existing customer or not in the middle of an evaluation, we have made this temporarily available at the following location on S3, Amazon S3. You can go download the zip file there. Notice that these are not spaces here, but these are underscores if you're going to manually type that in. The other piece of the component, this Android application that I have back here, is available on S3 as well. If you want to go and pull that down, the README in that project has a lot of information about setting that up and all the dependencies. So that is a good resource. And then lastly, you will need an Android virtual device or an Android physical device to actually run the application on. All of the application logic that we're using should be compatible with any API version, since Android has release backwards compatibility. I believe that's API 16 plus. My virtual device is specifically targeting the API version 28. If you open up your sample application, you go to your tools drop down, and in here you have an SDK manager. And then in the SDK manager, you have this little SDK tools window here. So you can go ahead and click on that. The important part here is to, down in the right-hand corner, show the package details, which will allow you to install older versions. So here we have the native development kit. You can drop down next to it. And here I have version 18 checked, as well as I have CMake 3.10.2 checked. I have these installed, so it's not going to have me apply anything. That Hoops Visualize SDK, I extracted it to this location where I have a bunch of other SDKs. When I click into that SDK, notice it's a way that the zip file works. It kind of has this like doubly nested layer. So you want to make sure that you're at this location where you have the bin, the include, everything like that. And you got to take your path and you need to set an environment variable. So you can go properties, and then, and I apologize if you know how to set one of these, but I'm just gonna go through this. So I go properties, advanced system settings, environment variables, and then I have a variable here called HPS Visualize Install Directory. I'll go ahead and type it there just so you can copy and paste if you want. And you basically just need to set that to the location on your file system that you extracted the Hoops Visualize package to, and go there and make sure that it has these contents. Alternatively, if you don't want to set the environment variable, because Windows is kind of a pain, and sometimes you have to like even restart your computer to get Android Studio to pick up the new variable. Inside of your solution, or inside of the project, if you navigate into the C++ file, there's a CMake lists.txt. And if you look there on line 5, this, I think I have this changed just to show it, but this in your system should be like $ in HPS Visualize installed there. So you can either go set that environment variable, or you can just open up this file and paste your path there. I would note that based on the syntax, you do need to do the double leading slashes. So you do need to escape those characters. Otherwise, it'll be like syntactically incorrect. So the Hoops native platform is a set of SDKs that TechSoft 3D offers. These SDKs offer cross-platform support, so they have SDK versions for Linux, Windows, Mac OS, as well as Android and iOS, and they also run on a wide variety of AR and VR devices. So specifically, the Hoops native platform is made up of 3 SDKs, Hoops Visualize, Hoops Publish, and Hoops Exchange. Today, we will be talking mostly about Hoops Visualize and Hoops Exchange. Hoops Visualize is a 3D visualization SDK. It specializes in high-performance 3D CAD engineering applications. So you can either create new applications from this, or you can integrate Hoops Visualize into existing applications to kind of boost their visualization and performance and stuff like that. The Hoops Visualize SDK has support for C, C++, and C#. Today we're going to be talking specifically about the C++ API and how we pull that into Java. It is also worth noting for the visualization aspect that this SDK has support for multiple graphics drivers. So I know like OpenGL, DirectX, and some of the other kind of bigger I guess standardized graphics drivers should be available through Hoops Visualize. So this is kind of the visualization side of things for your CAD data. And the other kind of big name TechSoft SDK is Hoops Exchange. Hoops Exchange is going to focus on CAD translation. So this is going to be an SDK that's going to give you access to essentially any widely used and adopted CAD format, file format. It's going to give you import from those formats and export to those formats. So there's a big variety of options for just like conversion with Hoops Exchange. And you also have the ability with Hoops Exchange to really like dive into CAD models and, traverse the relations between them and like pull out the information that you want from them. So it really gives you the ability to kind of take your 3D or your CAD engineering applications to the next level by really kind of empowering the data that you have access to. It is also worth noting Hoops Exchange is cross-platform, so available across most of your native and your mobile devices or I guess operating systems, I should say. So those are the two SDKs that are in the picture today. If you want to learn more about those, I recommend you go check them out on our site. There's tons of information there. This brings up the topic of Android native development, where we have an Android application and we need to pull in native dependencies to that. Well, this is achieved through something called the Java native interface. So the Java native interface is a programmatic interface developed by Oracle, the creators of Java, that basically allows the Java language to interoperate with a number of other native languages, whether it's C, C++, C#, even as low as assembly, and I think the list goes on and on and on. Today, obviously, we're talking specifically about C++ for that Hoops Visualize C++ SDK. But it is important to note that this Java native interface is that. It is an interface. It is not exactly a language. So a good example of that is over here on the right. If you're not familiar with the Java native interface, this is essentially what a basic implementation looks like. So at the top here, we have our Java class, and within our Java class, we have a function declaration with this keyword native. And that native is a very important keyword for the scope of this. Below it, here you will see a little C++ file, and you can see it's pulling in a JNI header, and then you have this kind of weird looking C++ where you have these weird JNI export, JNI call. And so that's what it is. That's that interface around it. And these keywords and this kind of interface structure allows the Java virtual machine to actually take a Java program and then pass its function calls into a C++ native library or a native library that has been linked. So if you want to look at it from a kind of a visualized aspect, this is what the Java native interface allows you to do. It allows you to take your Android code that you have over here on the left, or your Android application, and it basically serves as a method for you to pass through function calls and requests and data into your native libraries. So it works both ways. You can call C++ from Java, and you can call Java from C++. For the purpose of the Hoops SDK is really the only application, at least for our basic application today, is invoking C++ from Java, not the other way around. So it's going to look something like this, where we're going to create a very basic Android application here, and then we're going to wrap the Hoops Visualize libraries in the Java native interface, and that's going to allow us to bring that C++ visualization technology or software into the realm of Java and Android. The most fundamental building block of an Android application is what's called an activity, and an activity is where your Java logic lives. It's what gives your application functionality in life. One of the basic things that you'll be seeing today is a layout. A layout is essentially just going to define the visual structure of your user interface. Nothing fancy there. It's usually XML and doesn't have any logic. It's kind of like the HTML, right, of the Android aspect. And then lastly, the most important Android component that we're going to be using today in this demo is a surface view. Now, a surface view is derived from the view class, and a view in Android is exactly what you'd think it is. It's what populates the screen with content. So a view contains all of the content that you see. So in our case, we're using a surface view. which is a dedicated drawing surface that's embedded within a user interface. So you can just think of a surface view as a blank canvas. We're going to create that blank canvas and we're going to try to inject it into our visualization SDK. And then the C++ native code is actually going to render into this Android surface view component. So as we were talking about the activity kind of being the main entry point of the application, I think that makes the most sense to start out with. If I go over and I'm in my Android Studio now, here is the little sample application. If you're following along, you might notice that I have a little different model here. You should have a model, it's called conrod.hsf. It's over here in assets, data sets. There's the Conrod, I'm just using the BNC. It's just a little bit of a different model, but that won't trip us up at all. So if I was to go ahead and I was to close down this Android application, over here you can see I'm in app, Java, and in here we have 4 Java classes. Only one of them is an activity, and really we only need to mess with one of them today. So go ahead and open up the mobile surface activity, and this is where the bulk of our logic is going to be as far as invoking those native methods. So if I go ahead and I launch the application, you'll see that it's going to be pretty simple. It's just going to load in this file, and that's it. And it loads it on this canvas. So what's happening? Well, if you're familiar with an activity, when an activity is created, basically there's a method here on create that is invoked. So what are we doing when we do this? Well, the first thing we're doing is we're copying some data over. That data that we're going to render, basically we just have to copy it from the assets to the virtual device, so it's actually available to be read and rendered. So if you wanted to change like the model or anything like that, that's a good place to change your new, excuse me, that's a good place to load in your new model name, or just change what you should have there, conrod.hsf. You can change that to whatever model you have. So after we've loaded that model onto our device, one of the other important things is we have to load these native libraries. So here you can see the first part is the Hoops Exchange libraries being loaded if they are present. And then the second part is the Hoops Visualize. Hoops Visualize libraries being loaded. And this is actually loading the Java native interface libraries that are created by the CMake build, not the actual Visualize libraries from the Visualize distribution. So that is just something to note, that you can kind of see it's weird. The library name is named after the Android project because in the CMake lists, that is what this project is called. So that library will be whatever this value is there, if that makes sense. So we've copied our data that we want to render. We've loaded our native libraries. So there's not much left to do except actually start getting into creating the Java native methods that are going to allow us to do it. So over here, I mentioned that we have the mobile surface activity. This is the main entry point of the application, and it's pretty much up to this activity to instantiate or create an instance of a class that is able to access the visualized native methods that we would like to use. So here you can see, we talked about that surface view earlier, that surface view being that blank canvas that we're rendering into. So that surface view is being created and instantiated from this class, the Android user mobile surface view. I know that some of these are a mouthful, but hopefully they start to make sense in a little bit. So you can see next to the mobile surface activity Java class, we have the Android user mobile surface view class. So if you open up this class, the first thing that I would like to point out is this says auto-generated file. That's because we don't actually implement any functionality inside of this class here. If you look up here at the top, there's a bunch of these function declarations, and they are declared with that native keyword being important, as we talked about here, where that native keyword is what links or tells the JVM, hey, you need to go find the dependency for this native method and invoke it. So here you can see we have these native methods, and these native methods are invoked or essentially kind of wrapped up in these other functions. So looking back at our main activity, you can see we create that surface view, we create that class that's going to allow us to access the native methods, and then we add that surface view to the actual view that we're looking at in this activity. And then we also add this user code view. Just so you know, the user code view is what gives us these buttons over here on the right, as defined in the layout for this activity. So we have these buttons here on the right, and these buttons are what we want to invoke for the purpose of this. This is how we're going to call our native methods. So those buttons are tied to this callback function right here, toolbar button pressed. So if you go ahead and you look in here, you can basically just say, hey, we get a button is pressed. Which button is it? Based on that button, we want to go ahead and we want to invoke one of these methods on our surface view object. So we're going to jump back into this user mobile surface view class, and we can see that on user code 1 invokes this native method on user code 1v. So the naming is a little bit weird, and there's a reason for that we will uncover here. So these are our Java methods. Now we need to go find our native methods that we're actually invoking. We looked at the Java code and we kind of looked at that weird native method. So where is that native code actually living at? Well, in the app CPP, there's a couple files in here. There's a mobile app source and header file, a mobile surface source and header file, and then a user mobile surface header file. So there's only one of these only one of these files is important to us, and that is the user mobile surface file. If you look through the other ones, you'll just see some really kind of basic classes with not a lot there. These are basically kind of just setting up that hoops visualize scene. So mobile surface is built on top of mobile app, and then go figure user mobile surface is built on top of mobile app and mobile surface. So this is actually where our functionality lives. If you open up user mobile surface C++ and look through this and you compare it to, I'm gonna do two little windows here, and you compare it to the contents in that user mobile surface Java that was invoking the native methods with the native keywords, you'll start to see some of these function names kind of line up. We have on mode simple shadow, on mode simple shadow. So this C++ source on the left is actually what is being invoked from this Java code on the right. And as we kind of talked about earlier, excuse me as I misclick, as we kind of talked about earlier, there's that Java native interface, this wrapper that allows us to call from the Java to the C++. So what I've shown you here is the Java on the right, and we have the C++ on the left. So now the question is, where is this J and I stuff living at? Well, if we walk through that again, we have mobile surface activity. We instantiated that class with the native methods. We invoke those native methods, and those native methods are actually going to be invoked from in the C++. If you go into the J and I folder, the Java native interface folder, and you should see that the name of those files line up with the name of our Java classes that have those native keywords. So if you go ahead and open user mobile surface view JNI. In here, you will see this more kind of ugly looking code where you're passing in these J and I end and J long and J string. Basically, this is that interface wrapper around the C++ that essentially injects the JVM or the Java Virtual Machine state and all of that, and allows the native libraries to essentially be invoked. So in an attempt to, I realized that I just jumped between a lot of folders and a lot of files, and there's kind of this, it's kind of a little bit convoluted. So hopefully I can do this little demo right here that will maybe clear a couple things up. So I pointed out earlier in the slides that the user mobile surface C++ is where, that's where like our native library functions live. Like if you want to invoke the native libraries or you want to use them and develop with them, this is where you would do it. So for example, if I wanted to create a new library or like a new function, like I wanted to create a new function to invoke in my Android application, I could do something like int user mobile surface. Let's do on user code 5. Here, actually, I will just copy pasta because that's easier. Don't judge me. So we create a new function, user code 5 that we want to invoke from our Java. So I've created that in the C++. Of course, because C++, I need to also declare this in the header file. It is important to notice in this header file that there's this prefix surface action, and hopefully this makes sense in a second. We had talked earlier about the Java native interface, and one of the beauties of the Java native interface being a wrapper and not, or being an interface, excuse me, not a programming language, is that you can basically programmatically analyze existing C++ code and automatically generate the Java native interface code that you need for that to communicate with your Java application. So in our case, we just created a C++ function. There is an existing C++ function. So we would like to get that populated and generate the Java native interface code for it. There is a little bit of, there's a package that shipped with this, and it is called sip.py, SIP. So there is an open source piece of technology called Swig. It is a simplified wrapper and interface generator. And this piece of technology, Swig, specializes in analyzing existing native code and automatically generating the Java native interface code to make that invocable from a Java program. So sip.py is a take on Swig. And if we go ahead and we look at the sip.py script, you don't need to know a whole bunch about it, but what's important to note is these two values here, surface action and app action. If we go and we look at the user mobile H, see that we have the surface action that we prefaced here. What we're essentially saying is we're telling that sip.py, hey, anytime you see a C++ function with this surface action constant, we want you to automatically generate the code that needs, or the JNI code or JNI interface wrapper that it needs to be called with, and store that in our file. So if I was to go down here to my terminal and I was to invoke that sip.py script after adding this new function to the C++ source, you should see that it runs. And now when I update my Android user mobile surface view class, you can see here that this auto-generated file now contains on user code 5, a function that I declared in the source. So I know that there's a lot going on there, but I guess the important part is this sample project will allow you to just write the C++ code that you want, and then you can, when it builds, it will automatically generate all of that stuff in the middle that's really ugly and you don't want to deal with. And then if we go back into our mobile surface, all of a sudden, there should be a method here on user code 5. So it really takes out a lot of the work that you would need to do. Now, if you make really extensive changes to this project, you might have to make some changes to how the interface is generated. But for the most part, you should be able to integrate all of this into an existing project that you have. So you should be able to use our native libraries and use our interface generator and not have to worry about generating any JNI code, which is very nice. So hopefully that kind of demonstrates a little bit of how things are related, or I guess how we're able to access this stuff. So that JNI stuff is generated, and then the JNI C++ files that are actually then compiled and into their own native library, and then that is what allows them to communicate with each other, I should say. So when you're looking at loading this system.load here, what you're actually loading are the Java native interface libraries that are a result of everything being built. There are these functions that I was messing with earlier in user mobile surface C++ on user code 1, 2, 3, and 4. I added 5. You guys shouldn't have 5. If you navigate to user mobile surface C++ and go check out those functions, hopefully you just have some /to-dos and maybe like a print statement in there and really nothing else. So let's try to fill out those and maybe get you guys writing a little bit of visualize code and see if it works for you. And we are ready to start writing some code over here in user mobile surface C++. So if we start out with the on user code 1, you guys should have the /to-do with maybe a print statement or something in there. Feel free to delete all of that. Now, what I just did for this, it's a pretty simple functionality. The function that you need to call is already shipped in that solution that you have. But what we want to do is we have a scene where we have an object and we have a light. So let's just head and enable shadows for that really quickly. So we want that one button to act as a toggle. So, you know, false, true, false, true. So let's go ahead and let's create a global Boolean in the C++. Global variables are bad. I'm assuming if you guys are making a real application, you would have it a little bit more thought out. But so I just have a Boolean up here at the top of user mobile surface C++. It's defaults to false. By default, shadows are off. Once you have that declared up there, then you can go back in here. So basically the logic is if shadows are false and you click on this button, let's turn shadows to true. So we go ahead and we toggle that Boolean variable, and then we invoke this method that is defined up above on simple shadow with the new updated value of our Boolean. You can see on mode simple shadow. Now this is where we're actually invoking this HPS namespace is the hoops visualize namespace. So here you can see if we are enabling it, we're setting, you know, the settings on our shadow. We're invoking some hoops visualize library functions to actually create that shadow, set that shadow, and then finally we update the draw on the screen to reflect that change. So if you were to set that Boolean up above, you have these like so. I can just go ahead, push that over there. Keep sending PMs. There we go. That little snippet, it's 2 lines. Copy, paste it, write it out of front. And then if you were to build, you should see that now when you poke this one button, we get a little small, it's a very simple shadow. Notice that the rotation that we're doing is rotating the object and the light source and everything, so the shadow rotates with it. But obviously you can make things a lot more complicated, or I guess a lot more involved on your own. But that's just a very simple invoke some hoops functionality. Let's go on to user code 2 then. Feel free to just leave user code 1 there, and we are well on our way. So the idea for user code 2, what I did was Hoops Visualize has different rendering. Let me take a second there. Hoops Visualize has different rendering modes. So these include, flat lighting. The default, I believe, is Phong. And then there's like wireframe, hidden line, a bunch of kind of just different basic rendering modes. So let's go ahead and let's change on the fly how Hoops Visualize is actually using a render mode. So you can see in here in my user code 2, I have this switch case statement. So if you search this file for current rendering mode, if I can type, search it for current rendering mode, you'll see up here at the top when the user mobile surface instance is created, there is a variable current rendering mode that is created and set to an initial value of default. So what I'm doing is I am saying, okay, I want to switch on my current rendering mode. In the event that I am in my default rendering mode, I want to go to flat. So case rendering mode default, I update the current rendering mode to flat. And this is down in the Hoops Visualize structure, HPS rendering mode flat. When I'm flat, I want to go to wireframe. And when I'm in wireframe, I want to go back to default. Then after I've set that, I need to make sure to update the canvas with the new rendering mode. And then I have to redraw to get everything to take place. So unlike the last one, there's no global variables outside the scope of this. And the result here is build, and then 1 is our shadows, and you should be able to see that 2 will toggle the rendering mode. So we were in default, now we are in flat. You can tell because the surface normals look awful. From flat, we would go to wireframe. Here we're in a wireframe view. And then from wireframe, we go back to default. It's also worth noting if you have shadows on, just interesting, flat works, the shadow disappears for wireframe. I think that is just the way wireframe works. So for number 3, we kind of talked about this a little bit earlier. I was talking about operators and how there's some operators that ship with Hoops Visualize out of the bag, and then operators, or you can basically create or derive your own custom operators from the operator base class. So let's go ahead and check out a pretty cool operator that makes for a cool visual. And then we can actually maybe look at switching this to like a highlight operator or something. So we're going to implement the cutting plane operator. This is going to be somewhat similar to the shadow that we did, where we're going to want to toggle this operator on and off. So just like with the shadow, I have a little Boolean, global Boolean up here for the cutting. Is the cutting operator enabled? By default, it is not enabled. So you're going to go ahead and declare that variable up at the top. And then we're going to go ahead and we need to create our new operator, and then we need to load it onto the operator stack. So you can have multiple operators. You usually do have multiple operators in a Hoops Visualize scene. The operator control works just like any other stack. in computer science or programming or whatever, where it starts and it's empty, you can push operators on, and it's what a LIFO, last in, first out. So if you pushed 3 operators on and then you popped an operator off, the third one that you pushed on would now be gone and not working anymore in that scene. So for our case, we want to create the new cutting section operator. As I pointed out, if you look in your C++, there's the operators. We are using this SPRK, that stands for sprocket. Sprockets are kind of the way of a modular way of loading functionality in to Hoops Visualize. So you'll see here, if you go into the cutting section, we have this HPS cutting section operator. So this is where we are getting the name for that. So we create it. It's worth noting, just a little C-ism, that you have to create the pointer to it. We add it onto the stack, and then once you've pushed it on, it will be ready to use. But that's pretty much it. So toggle it on, create the operator, put it on the stack, toggle it off, remove the operator from the stack. In Hoops Visualize, when you remove an operator from the stack, when you pop it off, you are also freeing all memory allocated to that operator. So like here, we're creating a new operator every time we push it on, and that's because the old one is getting poofed into C++ garbage collection every time we pop it off. So do not worry about stack overflow or running out of memory or anything from this. So the result of this is the button 3 should now enable a cutting section operator. I click it and nothing happens. That's because this is how the operator works. So click it once to enable it, and then decide the surface normal that you would like to align the cutting plane with. So I'll click the very top here, and you can see we get this little plane here. Now you should be able to click on this plane and drag it through your geometry to toggle the visibility of it. So you can cut it wherever you'd like. If you click it, it's going to get rid of that operator. You can click it again, you can align it on a different plane and cut through. It's kind of cool to look at. And this is just one of the many operators that is included with out of the bag. So you'll usually, see a way in a Hoops Visualize user interface to enable operators and basically allow a user to interact with the scene how they would like to. So custom operators are a very easy way of implementing your custom logic with a really low, I guess, barrier to entry. So kind of just piggyback off all the stuff that Hoops Visualize lets you do. Load your models easily, get your canvas loaded, and then all you have to do is create your own little custom operator. Go ahead and create it, throw it on the stack, and you can interact with your models the way that you would like. So you would like to see, I know you had asked about a highlight operator earlier. So if we just wanted to do one of those really quick, we'll go ahead. I'm going to do a new Boolean for highlight. Let's go ahead. And instead of that cutting operator, go ahead and do I believe it is called highlight. 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 So now if I was to, I will actually have to build mine. Oh no. I messed it up earlier. I didn't fix it. So now when that builds, I'll let that go in the background for a second. we should have an example of the highlight operator. But I think that'll do it for the user code. I know, like I was saying earlier, I didn't want to get super deep into the Hoops Visualize SDK because I think we could talk about that for a long time. But hopefully, you know, that sample project there gives you an idea of how, you know, I guess how the Hoops native platform can get pulled into an Android application and how you can use it. Hopefully it gives you a place to kind of dive in and start messing around with the Hoops Visualize code. I know that more than likely, well, not more than likely, but if you want to learn more about Hoops Exchange is definitely one of our more popular SDKs just because of how powerful it is. So if you want to like get this application pulling in, you know, a whole bunch of different CAD formats, I definitely would look into the README for the project, and it mentions the variables that you need to set. You will need to download the Hoops Exchange SDK as well and extract it similarly to how you did the Visualize one. But we also have some training sessions from previously in the year, explicitly one that talks a lot about Hoops Exchange. So that is a good YouTube video to go check out and watch that session if you want to learn more about, you know, what is Hoops Exchange and what can it do for me. If we go look at that mobile surface activity in that onCreate method, I'm going to jump around a little bit more on here. Sorry, when we had that step where we loaded our native libraries, you'll see that the first thing we do is we try to load these two libraries to see if they're present. These are the Hoops Exchange libraries, and if those are present, then we toggle this using Exchange flag on. This is important if you go into user mobile CPP and you expand this load. No, sorry, it's not load file. It is. Okay, here it is. It's right in front of my face. So you can see here there's a method that already exists for import point cloud file HSF. HSF is Hoops Visualize's proprietary file format, and then here's the STL and the OBJ loads that Jonathan was talking about. So these file formats are supported with just Visualize. If you're using Exchange, if you expand this, you'll see that there's a method import Exchange file, and in here there are a number of different files that are imported. If you have questions, if you need help with something else, whether it's related to what we talked about today or it's just related to other Hoops projects, or excuse me, products in general, feel free to, you know, ask us questions or anything like that. But we'd like to thank you all for being here and spending this time with us. So we hope it was worth your while.